Alright class, we are on to our next section of notes in chapter 10 called Angle Relationships and Circles. And so our first definition, which is a previous definition that we know from 10.4, is a circumscribed angle. And a circumscribed angle is within the circle that contains the vertices. So this is where we have angles inside vertices. Sometimes we'll have angles outside of their circle and things of that nature. So that's what most of this section is going to be about. So we're into the first theorem for this section, and it is tangent and intersected chord theorems. And so it kind of helps to know what linear pairs are in this section, because a tangent line and an intersected chord can kind of create linear pairs, and we know linear pairs are supplementary. So just keep that in mind as we go through things like this. So in our tangent and intersected chord theorem, it says if a tangent and a chord intersect at a point in the circle, so for example here, then the measure of each angle formed is one half the measure of its intercepted arc. So for example, we have this one. It says if we were to find the measure of angle 1, we would take half of the intercepted arc AB. And if we wanted to find the intercepted, or find the measure of angle 2, we would take the half of the intercepted arc, which is BCA. Okay, so in this example that I have pre-drawn, let's say we want to find the measure of angle 1. And so we already have the intercepted arc of angle 1 is 240. So I know angle 1 would be half of arc AB. So that would equal 1/2, and AB is 240. So the measure of angle 1 is 120 degrees. And so simple enough. So now we know that angle 1 is 120 degrees here. Now say we wanted to find the measure of angle 2, and I want to put this on the other side of 1. This is kind of where it helps knowing linear pairs. And so if I wanted to find the rest of that, I could take 120 and subtract it from 180 to get the measure of angle 2. Okay, so we have our core concepts, which is intersecting lines and circles. And so if two non-parallel lines, so non-parallel means they intersect somewhere, if they intersect a circle, there are 3 places where the lines can intersect. We can have it on the circle, so here on the edge. We have it interior or inside the circle, or exterior or on the outside of the circle. So those are the 3 places that if 2 lines cross, they can hit somewhere on this circle. So on to our next theorem. We have angles inside the circle. So 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs that are intersected by the angle. Okay, so that means if we have to find measure of angle 1, we would add the intercepted arc AD and DC. If we wanted to find the measure of angle 2, we would need to add the intercepted arcs AD and BC. And so that's how we would do that. And we can always just find 1 and 2. Again, these create a linear pair, and we also have vertical angles involved. So just keep those in mind when we start finding more than one set of angles. So if we wanted to find the measure of angle X, we know that measure of angle X would be, if we're plugging our formula, 1/2 the sum of our intercepted arcs. So here and here, which is 130 plus 156. And so I have 1/2 times plus 130, or times 130 plus 156, which gives me so 130 plus 156 gives me 286, and divide by 2 gives me 43, or 143 degrees. So that's how we apply that concept there. And so let's move on to our next one. Our next theorem is 10.16, angles outside the circle theorem. So anytime we have angles or have a point outside a circle, we're going to take the difference. So we still have that 1/2, but this time we're taking the difference. Note we can't have negative, so make sure you put the bigger number in front this time. And so this is what you use if you have it outside the circle. So you take the big one minus the small. Same here and here. And so you take that and subtract it from the rest. Or if you're going the other way around, you might have to multiply by 2. So I have 2 examples written here in order to better understand that. So say we want to find x in this example. So if we want to find x degrees, we know that we're going to use this one because it does hit outside the circle, but it kind of hits a little bit underneath it, and that's okay. So you're going to take 1/2 of arc DA minus the smaller arc BD. And so you have 1/2 of 178 minus 76, and you get a total of 51 degrees. So angle X in its corner is 51 degrees. Now on our other example, we're going to do this very similar thing, except now we're trying to find the outside. So we need to find the measure of angle A. Well, we know that our small one, we're still taking the difference, our small one equals 1/2 the difference of the outside, which technically would be A, minus our smaller arc, which is 44. So in this case, I want to get rid of that 1/2 first, so I'm going to multiply by its reciprocal. So times 2 over 1 on both sides times 2 over 1. And that way I don't have to worry about a fraction. No, you do not have to distribute. If you distribute that 1/2, it'll make your algebra a little bit more complicated. So now I have 2 times 30 equal A minus 44. And 2 times 30 is 60. I'm going to add 44 to both sides. So I have 104 is equal to A. So A is 104 degrees. Okay, so that completes those 2 examples. And then we're going to hit our next example, which is talking our core concept on the circumscribed angle. So a circumscribed angle is an angle whose sides are tangent to the circle. So this kind of like lays on top and bottom. It does not cut across it in any kind of way, even though they do meet at a point. So we're going to apply a theorem to this. So the measure of a circumscribed angle is equal to 180 degrees minus the measure of its central angle. And so if I wanted to find ADB in this case, and then I have to subtract 180 from the measure of ACB, so I have to use that theorem. So for example, say if I want to find ADB here, and I'm given 135, and so I know if I want to do that, I take 180 minus the measure of ACB, and ACB is 135, so I have 180 minus 135, and I get 45 degrees for X. Or in this case, ADB. Okay? So let's try another example. It's a little bit more complicated because this does not hit all the way here, doesn't go to the center, it goes all the way to the edge. And so I know if I want to find EJF, I'm going to take 1/2 of EF. And so I'm taking 1/2 of EF just so I can get the other part of this X. But EF's arc is coming from here. So I'm going to 1/2 180 minus the angle of HF. And so I have 1/2, 180 minus 30 gives me 1/2 times 150, which gives me a solid 75 degrees. And so that one's kind of applying an extra theorem because this comes from the angle measure of EGF. Okay? And so that's a little bit harder example, but you will need to know it for upcoming uses. And so on to our next page, we have our examples for our extra practices. So here are our extra practices. So I want to find the measure of each angle. And here is my tangent line and my chord. And so I'm already given 70 degrees. And number 1 wants us to find A, B, C. So he wants to find this part here. Note I talked about linear pairs. And so remember, a linear pair adds up to 180. So keep that in mind. So if I want to find 70, or find the measure of ABC, I take 180 minus 70, I get 110 degrees. That's because of linear pair. I'll abbreviate. Now I want the measure of AB, so arc AB here, and so this is where I apply that 1/2. So I know that 70, or at least this part, will equal 1/2 of my arc AB. But I don't know what AB is, and note I can always multiply by 2 on both sides to get rid of that half. And so I have 2 times 70 equals arc of AB, and so AB equals 140 degrees. Okay, and then we're going to do the same thing over to our other side, except now we know that this is 110. So we have 110 equals 1/2 of AEB. We're going to multiply by 2 to get rid of that half. So 2 times 110 equals EAB, and EAB is 220. Okay, or you can always subtract it from 360. Alrighty, so here is number 4 and 5. We have ADB is 220 degrees. So from here all the way past D, all the way to B is 220 degrees. And then we have angle B is 21 degrees. So right here is 21 degrees. And it says find the indicated measure. So number 4, we have A, trying to find arc AB. So in this case, we know a full circle is going to be 100, or it's going to be 360 degrees. So if I want to find the rest of my arc, all I have to do is subtract, because a full circle is 360. I would take 360 minus 220, and I get 140 degrees. Okay, so on number 5, we're looking for ACB. So ACB is, use a different color. So ACB is here, so we're trying to find that angle around C. And before I do that, though, it might be helpful to find this arc. And so to find that arc, I have to use that half, or 21, or I have to multiply it by 2 to kind of get this arc based on 10.4. So if you don't remember that, please go back to 2.4 and to review those notes. So I would take 21 times 2 to get 42, and that is the measure of this arc. So I have 42 degrees. So now I have two numbers in order to get my x value or angle C. So this would equal 1/2, and it's on the outside, so I'm using the difference to get 140 right here. So I'm using the difference of my intercepted circle, so I have 140 minus 42, so I get 49. Okay, so in this one we use our AB to find that intercepted arc. We have to multiply by 2 to get a little bit of this arc left, and then we use the difference in order to find what C was. Okay, so we have 4 more examples left. So number 6. So for number 6, I need to use my half, and because my intersection is inside, I'm going to add my arcs together. So I have 1/2 of 92 plus 50, and if I were to put these into my calculator, I get 71 degrees for x. Okay. And then for our next one, we can still find our intercepted angles. We are solving for x. However, I kind of need to know what this side is, especially since I'm given the intercepted arcs. And so let's find out what this angle, these angles are here. So I have 1/2, 97 plus 35, and I get 66 degrees. So this part is 66 degrees, but note we talked about linear pairs, and so if I were to get the measure of this part, it should equal 180. So if I add 66 plus 5x plus 14, it should give me 180 degrees. So I'm going to add like terms, and I'm going to subtract 80. I get 5x equal to 100. I want to divide by 5. X is 20. So note this is where you can use linear pair in order to find your inscribed angles. The next one at the bottom, because it is on the outside, I'm going to use the difference. For this one, number 6, I use sum. Number 6, I use sum. I use the difference here. So, if I want to find x, I know that our small number here, 38, will equal the 1/2 of the difference. And remember, our big one goes first, so it would be x minus 72. So remember, in order to get rid of that half, I'm going to multiply 2 on both sides. So 2 times 38 gives me 76, and my half and my 2 are gone. I'm going to add 72 to both sides, and so x equals 148 degrees. And note you can always go backwards to see if your numbers make sense. You can always go back and check your work. Number 9, our last question, again is on the tangent lines this time, and we're solving for x. So if it is on the tangent lines, we know that we are going to subtract. They're on the outside. So I have 28 is equal to 1/2 parentheses, and I would put these in parentheses like they are given, 4x plus 8 minus 3x plus 2. So I'm going to multiply by 2 on both sides. Sorry, I've run out of room to get rid of that half. And so I'm left with 2 times 28 on one side, which is 56. And then I have 4x plus 8. I'm going to go ahead and distribute my negative. So minus 3x minus 2. Alright, now I'm going to add like terms. So I have 56 equal x plus 6. So if you're adding like terms, 4x minus 2x is 1x, and then 8 minus 2 is 6. Then I'm going to subtract, so x equals 50. Alright, and that is our last example. Note, I do have tutoring on Wednesdays and Thursdays from 3 to 4, and if you are in need of me, please feel free to find me on Remind, or shoot me an email at mariahmartin@mistmail.org to schedule a tutoring appointment. Thank you so much, guys, and y'all have a wonderful day.